Well, this is super exciting. I'm here with Meryem, and we are live again with Inspire to Build. So well, if you've been here before, my name is Erica Hughberg, and you've met me before. So I'm not that interesting, but Meryem is way more interesting than I am. If you are joining us live, please pop a hello in the comments, say where you are joining from. It would be lovely to hear where you are joining from. But Meryem, where are you joining from and who are you?
Hello from London. I am Meryem Arik. I'm the co-founder and CEO of Doubleword. We are an inference company, specifically focused on like large-scale inference. You can kind of think of us a bit like Costco, but Costco for tokens. We sell tokens in very, very large bulks.
Costco. Okay. By the way, Costco is pretty like established in the UK nowadays as well,
Yeah, I
I
love
guess.
Costco.
We love Costco. It was so funny when my husband's mother came to the US. We live in the US nowadays. By the way, if you do not know me, I used to live in the UK. I am from Sweden, but I live in the US nowadays. But my husband's mother came from the UK to the US, and she's quite a short woman. This is a way detour, but we had her push one of the Costco carts. It was very, very exciting. Uh, the, the, the proportions.
Yeah, Costco's
But
great.
yeah, very exciting. However, so you are like Costco for inference, and you you have been around for how long as a
So
company?
we started as like a research collective,
Okay.
an inference kind of research lab, if you will. And we started before ChatGPT came out
Oh
of kind
wow.
of PhD postdoc research that our team was doing in the computational quantum physics space. So actually not entirely inference related, but a lot of the maths transfers over. And
Yeah.
so we've always been interested in how to make deep learning models more efficient at inference time. And it started out as a research project and us doing kind of lots of interesting
Yeah.
things like uh, we worked on methods like quantization and fine pruning to
Yeah.
allow you to make smaller models that were as good quality that would be easier to inference. And as the space evolved and kind of as we evolved, that turned into a company. But we're still working on the same things of how to make deep learning models and language models and LLMs more efficient at inference time, because
Yeah.
they're more efficient. There's kind of a fun thing that the more efficient a thing is, uh, it's not like people then bank the savings. People do more of the thing, and
Yeah.
so the more efficient that we can make like these kinds of models, the more value that people can get out of them, and so that's really what we work on.
And if you if you come back, so you started as this inference, like the research collective, and what really inspired the beginning of getting together and starting this company? What brought you all together?
Um, so doing science with your friends is fun, and so we were a group of friends and um, working on like interesting hard things together is like just a fun thing to do. But maybe I can talk a bit about like why we saw the insight that like inference was going to be a big problem, because at the time
Yeah.
it was obvious that inference was going to be a problem. So
Yes, please.
at this time, um, th-
And
this
what was
was
the year?
this was in 2022. Some of the
Yeah.
research started before in 2021 and
Yeah.
earlier. And this was at a time where people weren't interested by inference costs really at all. What people were
Mm.
really focused on like training costs, because it was before, you know, the mass adoption of like pre-trained models. And so everyone was like training their own models for their own use cases. And so the costs that were dominating were training costs. They were the really big thing. The insight that we had was after seeing models like GPT-2 and like early versions of GPT-3, which then became ChatGPT,
Yeah.
we saw that there was like a lot of potential with these pre-trained models.
Mm.
Um, and if it is the case that these pre-trained models were going to continue getting as good as they were getting, if the rate of progress was going to continue, we noticed that the thing that would matter would not be the training cost, because you train once, and you train once and it's expensive, and who cares if it's expensive? It happens once. The thing that would be expensive and difficult would be the inference costs and optimizing for inference, because once it's pre-trained, you're using the same model over and over and over and over again, and the more useful it is, the more you're using it. And so we kind of looked at the rate of progress in the space, and just made this bet that if the rate of progress continues to be good, the big bottleneck is not going to be training anymore. The big bottleneck is going to be actually inferencing and running these models.
And so you realized that this cost was going to be important for people who were going to build AI-powered solutions. And you decided to start a company around it. And how are you actually solving it? Like, how do you solve inference cost? Because it seems like a equation that you can't really fix, or am I wrong?
Well, so I think something that's important to understand about inference is it's actually a game of trade-offs. And so you can't have everything all at once. And it's a trade-off of three things mainly. You have this kind of triangle. You can trade off low latency, high quality, and low cost. And you can have like two of the three, right? So you can either have very, very fast, very high quality tokens, but then they're expensive. Or you can have very fast, very cheap tokens, but then those tokens are probably dumb, like they're not smart. Or you can have low cost, high quality tokens, but then they're going to be slow. And so it's always this game of trade-offs, and like some of the very early work we were doing was in trying to increase the number of options you can make with those trade-offs, improve that.
So if I'm doing, for example, overnight processing, if I'm analyzing things overnight, I might not need fast tokens.
Exactly. Yeah. And so you wouldn't need fast, and then you would say, I actually just care about the cheapness and the quality. And so what inference is about, and you make different optimizations depending on what you're trying to optimize for in your inference space. But the first thing that you need to understand is, like, out of this trilemma, out of this like triangle, what are the things that I want to optimize for? Do I want to optimize for cost? Do I want to optimize for latency? Do I want to optimize for quality? And you're going to have different trade-off choices depending on your use case. So as you say, if I have overnight batch processing, I don't care about latency. I just want to be able to process a lot of tokens for not very much, and they should be fast. If I'm doing a coding assistant, I need it to be super, super, super low latency, and I might not care about cost because the value is really, really high. So once you understand the trade-offs, then you can, the trade-off for your use case, you can then decide what you do.
Yeah, I wanted to bring up some comments here on the screen, so they're visible. But yeah, so Faisal commenting here live. Anyone can comment live. Say if you have any questions or comments, feel free to jump into the conversation. But yeah, I think Faisal there was talking about the trade-off between cost, speed, accuracy, and I think that's also an interesting question. Accuracy and quality. How do people measure that, Meryem, when they look at models like accuracy, quality? How do you help? Do you help your clients understand quality and accuracy? How do you even look at that? Is that a really hard space?
Yeah, I think the space of evals is really difficult. And so there's a couple things you can do. There's the first one, which is like to understand what models are in the same ballpark. For that, I would recommend a website called Ella Marina. Essentially, they use kind of blind ranking, so blind preference choosing, to be able to rank models, and they give every model like an ELO score, kind of like in chess, and it's kind of like a similar mechanism to chess scoring, and that can tell you what models are in like the same ballpark. After that, once you've got kind of the same ballpark, it typically works better if you have use case by use case evals. So what a model might perform well in for one use case, it might not well perform that well in another use case. And also your prompt will probably have to change from model to model. And so we recommend that our clients kind of put together an eval set of like representative questions for their use case,
Okay.
test models against that. But also like what we see in like a lot of our clients is a lot of it is vibe testing, like just like
Oh,
vibe checking. Like, does this kind of
like
feel
vibe,
like the right
check
kind
the
of
vibe.
answer? Yeah, because like these large language models, they can give you the same answer, right? The answer can be correct, but actually there's like a lot of preference that the human
Mm,
has in terms of the way that it presented the answer, the way that it said the
mm,
answer. And like a lot of that is just vibe testing and vibe checking. And so a combination of like ELO scores from Ella Marina, like use case specific evals, and then also just like vibe checking with experts is what we see.
And do you see people actually asking for feedback from live users apart from their own employees?
So what we have seen people or some of like
Or like from end users, you know,
the
like,
best
yeah,
sometimes the best like AI engineers is building in like ongoing feedback loops. And so
mm,
having the like thumbs up, thumbs down that you see in all AI
yeah,
services, you might ignore it, but like it's actually kind
yeah,
of helpful if you do thumbs up or thumbs down,
yeah,
because you can then use that data to do a bit of reinforcement learning and also a bit of like further tuning. And so we do see people building in those kinds of like either thumbs up, thumbs down, like rate on a scale of 1 to 10, kind of feedback. We also see people building in more implicit ways of getting feedback for whether the answer is good. So, for
yeah.
example, um, one one way of measuring this is, let's say you are providing an AI service that helps people like draft emails.
Ah,
Do they, for example, accept the version you give them, or do they
mm.
edit what you give them? If they do edit, how many times do they edit? What do they edit? All of this is like really, really valuable feedback for you to know whether your application is performing well.
So when you have, so your solution at Doubleword, do you only, this sounds bad, do you only provide hosting? You provide hosting solutions, right, for the inference. Do you provide other services around the hosting?
Yeah, so
What?
our main
Yeah,
kind of our business is providing tokens.
yeah,
And we provide tokens for like all different use cases, all different models. And specifically we provide tokens and inference for use cases where people are happy to trade off latency and want to
mm,
have a very, very low costs. So
yeah,
when I say the cost of inference, what I mean by that is people want to make the trade-off that we were talking about earlier
yeah,
of low cost, high quality tokens, which probably means they're inferencing in bulk as well. And
yeah,
so we provide tokens that have that kind of trade-off, and it means we can
yeah,
provide really, really, really low cost inference
yeah,
price. In terms of like services right around that, we see a lot of different use cases. And
mm,
so although we don't have like, for example, we don't actually provide use cases on top, we see a lot of different use cases and have like kind of best practices of what we
yeah,
see from all of our clients, what we've seen from them
yeah.
has worked and what hasn't worked.
And what what is the experience? I'm really curious actually. So what is the experience for someone who is building on top of Doubleword? Like what is that like? Like if you, so obviously if I go and use OpenAI or Anthropic or whatever, like I know what it's very much like to go and build on top of those. But what is it like if I build on top of Doubleword? What is that
So,
like?
so we, in the ways, in some places, it should be identical to building on top of OpenAI and Anthropic, and in some ways, it should feel very different.
Mm,
And so, what I mean by that is, um, inference providers should be easy to switch in and out. So, for
okay.
example, it should be easy for you to switch from OpenAI to Doubleword to Anthropic to all of these other
Mm,
providers. And so the DevX that we build around that should make it really, really easy for you to switch. Now, as like a founder, that obviously, is challenging for me, because then I need to make sure that I'm always offering really competitive prices. I need to make sure I'm always providing a really good experience.
Yeah.
In terms of like APIs, we're compatible with OpenAI API, so it's very easy to switch to and from.
Yeah.
And so in that way, it's very, very similar. But there are places where we've built it to be much better. So all of the other inference providers treat large-scale batched inference as an afterthought. It's kind of
Okay.
like they're built for real time, they're built for chat applications. And so the batched inference is like an afterthought. And what that means is like there's a pretty poor DevX around batched inference. And also the prices are way higher than they should be. And so we've really thought from the ground up of like, what should the DevX for batched inference be? And what that means is we have things like not just a 24-hour SLA, but we have like a 1-hour SLA for batch inference. And so you can start doing offline agents and like chained calls, which is really cool. Or we start returning all of the requests as soon as they're done processing, not just like at the end of the batch. And so people can start, can keep building. And so it's just to summarize, like we're very similar in that it should look a lot like other inference providers because it should be easy for you to switch. But we also want to give you an experience and a DevX like built and designed for the workload that we're serving.
Okay, so we have a few questions that come in. I can put them up. Let's take them in order. I'll put them up on the screen. So how do you handle that complexity of supporting different inference engines and optimization techniques, assuming you run into this often? I assuming that is diversity around deployment targets across your customers.
Yeah. It's a great question. So the inference space can be quite intimidating for people that like haven't been in it for a while. There's like a lot of different inference engines. If you look at like VLLM, which is the most popular inference engine, it's got like 1,000 different flags, and you never really know what you should be turning on or turning off depending on your workload. So there's like all of this changes depending on the model you're working on and depending on the hardware you're working on. So the combinations are really kind of intimidating. One reason why we are the right people to build the company that we're building is we came from an inference optimization background. And so we came from like a really, really deep understanding of inference and how inference works. In fact, we built an inference engine from the ground up before like VLM existed. And so because we come from that really deep inference optimization background, the complexity and of understanding inference is like not the challenge for us, because that's where our backgrounds are. But that is where we're able to like offer value to our clients, because for example, we understand what trade-offs you need to make if you want to produce really, really cheap tokens, but our clients don't need to worry about that. They just buy the cheap tokens. And so that's kind of where we add the value. But yes, it's like not trivial in understanding like the different complexities and trade-offs. And I guess that's like we spend a lot of our time, for example, profiling and benchmarking different inference engines, different hardware for different use cases. Only yesterday, our CTO released a VLLM profiler simulator, which you can check
cool.
out. And so that's like available on GitHub, which you can play with like different knobs and stuff.
Is that, by the way, Meryem, is that available at all via the GitHub link that you shared with me earlier, or is that not on that GitHub link that you shared with me earlier?
I can share it this second, actually. So it's inference here you go. I've just posted it in the comments. So inferencelab.doubleword.ai.
Put it up here so people can check it out.
Yeah, you can play around with it. It's something that our CTO built over the last week or so. And so like this is some of the work that we do, like constantly trying to figure out what the right trade-offs are to make for the right use cases.
Oh, that's super interesting. So if people want to check that out, you can check that link out and start that there. Hopefully for those, depending on which platform you're tuning in on, you can see that link. Otherwise, obviously I'm sharing it on the screen there. And we have another question, which is a very long question. So I'll hide it in a second because we cannot see Meryem's face. So when you're building a product and start meeting your initial customers and getting feedback, let's say 80% of the feedback validates your concept and the rest of the 20% motivates you to add a new feature that looks very important to every customer. How do you define the boundary between which feedback to incorporate from the customer and which to keep for the future?
Yeah, this is a hard question, and I don't think there's like a perfect answer. Um, so I think it's very important. So when I think about prioritizing feedback, a way that I think about it is you want to have kind of a long-term vision and mission of like where you're trying to take the company. And so feedback that takes you completely off that path is typically not feedback that I would incorporate unless it makes me no longer believe in this long-term vision. So for example, and you often get this from like really, really big customers where they'll say, actually, the thing that I really need you to build is this X feature, which is actually kind of perpendicular to the direction I'm trying to go in, which you might do, and you might do in order to land that customer, but like you have to think really carefully about it. And so I kind of think about, does the feature request that I'm getting actually take me towards the world that I think is going to exist? Because you always want to be skating kind of where the puck is going. Is that taking me towards where I think the world's going to go to, or is it actually just a bit of a distraction? And so understanding that is really valuable. Another thing to understand is, especially in early days, you don't actually have that much feedback. And so you might get feature requests from one or two people, but it's really hard to know whether that is a big enough sample size to listen to if your overall sample size isn't big enough. And so doing everything you can to kind of increase the overall sample size of number of people you talk to is really, really valuable to understand whether the feedback you're getting or the feature request you're getting is actually like statistically meaningful, or if it's just like this one or two people who had this particular constraint. I've had this exact experience very recently. So one use case that I'm really excited by is offline agents. So agents are kind of like,
tell us more. That sounds super interesting.
Yeah. So as models are getting better and better, we're able to trust them to run for a longer and long period of time. They can take on not just a particular micro task, but they can take on like a whole workload. Deep research is an example of this, but
Okay.
you could imagine like offline agents that just run overnight and essentially do like a whole job, or like a whole kind of suite of tasks. And so as models get better and better, we're going to see more and more of these offline agent jobs. And these are interesting jobs because they're not time sensitive in that it's just running in the background. I don't need a human to check it every minute. So I maybe need my result within 12 hours, for example. It just runs it. But these offline agents are typically constructed of hundreds and hundreds of LLM calls. It's actually just like, it's not just one model doing one inference. It's using a tool, and then kind of it's thinking, and then it's researching, and blah, blah, blah. And then it kind of goes on and on and on in the background. And the way that people are building this at the moment is by using real-time APIs. And the reason why is because anything other than real-time APIs would be way too slow. Because if I have using a batched API to do this, I'll have 24-hour per call.
Too slow.
Way, way too slow. But I also don't care about it being that fast. And I'm producing a lot of tokens.
You need something in the middle.
You need something in the middle, right? Exactly. So you end up in a situation where the offline agents built at the moment are just like really expensive, built for infrastructure that doesn't really make sense for it. And the only other thing that exists is like these batched workloads, and that's way too slow, and you need something in the middle. And so I've been thinking a lot at the moment about what inference experience do we need to build to be able to support those kinds of use cases. And so I've been speaking with customers and speaking with users about like, tell me about these workloads, and like, what could an inference experience for that look like? And so I can give you some like ideas that customers, like I've talked about with customers. One could be just like a slow API. So you could imagine a situation where it's like kind of real time, but it's just slower, which makes us make it a bit cheaper. You could have other ideas, which is more like, I don't know, a DAG level SLA. So instead of giving a 24-hour SLA for each LLM call, I can give a 24-hour SLA for the whole process. And maybe we run the tools on our side, or maybe we call back to them to run the tools on their side. And so like there's like with these kind of I've seen where the puck is going, which is these offline agents, and then we can work and iterate with clients of like what is actually the best way to deliver an inference experience for that use case, which isn't that.
This makes a lot of sense. So for those who do not know, I used to work in financial technology, fintech, but in asset management and financial analysis. And I hear this parallel, which is so striking at the moment, because we used to deal with portfolio analysis, and in the when you had a financial analysis platform and software clients of this type of platform, some clients needed to analyze a portfolio like software clients, so they were managing money themselves, but they may not need the response immediately, exactly like you said, but they may not want to wait 24 hours, right? But they were willing to get a cheaper price to analyze the portfolio. They were like, I'm willing to wait. I'm willing to go in the slow queue, right?
Yeah.
I don't need to be in the fast queue like at Disneyland, right?
Yeah.
I don't need to get on the ride first. I can go in the slow queue and wait a little. Other people can get a fast ticket, right? And I think that is a quite interesting. But I want to get on the ride.
Yeah, I want to get on the ride. I don't want to wait 24 hours. So like if you bring up the link that I shared with you earlier.
The link.
So,
do you want to show the?
Yeah. So like the way that we've solved this right now is a little bit clunky, and it's not the perfect way to solve it. So most batch inference providers just provide a 24-hour delivery, or 24-hour SLA. So I wait 24 hours and I'll get my response somewhere within 24 hours. But let's say I have a data processing pipeline that has 7 steps. I'm not going to wait 7 days to get my response if I'm using this 24-hour thing. So what we've built in the meantime is a 1-hour delivery SLA option. So this is an option where it's a little bit more expensive than the 24-hour SLA, but it's still much, much, much cheaper than the real-time SLA. And it means that you get your response in an hour. And if you have 7 steps in your data processing pipeline, it's only going to take 7 hours, which is acceptable.
Yeah.
And so this is an instance where we're taking people from real-time pricing. So this is a similar quality model from OpenAI. This is the price, so pretty expensive. Taking them from real-time when they couldn't get access to batched APIs because it was too slow, and we've given them an intermediate option. Now,
that's so cool.
It's really now long-term, I think there's actually smarter ways to be able to provide the offline agents inference experience, but this is a intermediate step, like works really, really well for a lot of our customers. Waiting 1 hour per step is totally acceptable, whereas waiting 24 hours isn't. And I can then save you like 80% of the price, which is really valuable.
I think it's really interesting. I think it's really taking a step in the right direction. And I think this is sort of also coming back to the question that was asked earlier around how do you prioritize features? How do you come to features that are taking you in the right direction, right?
Yeah.
And sort of navigating that ship towards the destination.
And one thing I should add to like his question earlier is also prioritizing based on how easy or difficult it is for you to execute. So it's actually relatively easy for me to add in a 1-hour SLA if I hear that this offline agents is an issue. And so adding that in as a feature and understanding if this is really a problem because it's easy for me to do, while I think of like what the harder, longer term solutions to do is also a really valuable way to think about it.
Yeah. If anyone has any more questions for Meryem about this sort of medium, like, well, I don't know what to call it. It's not really.
It's kind of
What
like
do you want to call
slow.
it? Medium batched up, medium.
Yeah, I need to come up with a good name for it. Like, it's not like a slow API. It's kind of somewhere in between. But I think where our space is going, so in the batched or the slow inference space that I'm in,
Yeah.
most of our use cases at the moment are like data processing, data document processing use cases. Within the next 12 months, I think the majority of tokens will actually be offline agent tokens. And so I need to build for that reality. And so this is like a step in that direction, but there's a lot more and interesting things we can do with the DevX around offline agents.
Thank you so much for also sharing this like UI perspective, because I think it really also helps put a visual to what it looks like.
Yeah, if you want to check out the website as well.
That's really helpful. Thank you. Just showing the link there on the stream as well, so people can check it out. Also, if you want to connect with Meryem, just going to shout that out here. Like, if you want to connect with Meryem, she is very friendly. I just want to let you know. Here's her LinkedIn QR for her LinkedIn as well, so you can always bother her online. I'm sure she likes talking about Doubleword because she's already chatting to me about it. And she's probably happy to chat to you about it as well. So don't worry. I tell her that you're allowed to talk to her about it.
Yeah, I am. I try to be very friendly anyway.
Yes, you are very friendly. So absolutely. I hope no one will feel like it's scary to talk to you. And I was gonna go back to show Covens on the stage. So if I'm clearly clicking all the buttons there to show all the things, but yeah, if people have questions about these APIs, feel free to drop them in the comments. And what I just want to come back to, like, what really triggered you to believe that this was, like, what made you believe that this was going to be so first you saw we talked about you believing and seeing this opportunity of batch and offline sort of processing of inference. And we talked about how now you spotted the opportunity of sort of faster offline agents.
Faster, slow.
Faster, slow. And we talked about these offline agents. By the way, I kept thinking in my head when you talked about that, about travel planning agents, because I've been doing so much little travel planning myself lately, and it's so time consuming to find all of the little gems in different places where you go in. And I do my best, right, leveraging AI to help myself search the internet for things. I did find a cute little restaurant for New Year's Eve, by the way, with help of AI. Hopefully it's good. I booked a table. But I think that there are so many things that doesn't have to be real time, by the way. I could go to sleep even and let agents do travel planning for me, right? And maybe jobs like travel agents, people who are travel planners, they could have multiple clients like me, and they could kick off jobs overnight and come back with drafted plans for multiple clients to help them, right? So there could be solutions to support people like that, and many, many other jobs, right? Not just travel planners. That just is my current life, planning my own travels. So that was top of mind for me.
Yeah, I mean, the only time that low latency really, really matters is if you're actually supporting a person in doing a task that the person is doing, and you're actually supporting that person. As these models get better and better and better, we can actually just like offload entire processes to them. So the reason why coding assistants need to be super low latency at the moment is because they're not good enough to run off and like just write code. They need humans to say yes, 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 or no, no, no.
They need supervision.
But if they got 10 times better, they would need to come back to the person every hour and say, hey, look at look at what I wrote. Is this what you had in mind? And then you can give them feedback the way you'd give a normal colleague feedback.
That's a really good insight, actually. The better the models get, the more they can operate independently.
Well,
And that is why we can actually do it slower, which in theory then could lower the costs of inference.
Exactly. So let's say my coding assistant makes a mistake 1 out of 10 times. So it has a 90% like correctness rate. That is way too inaccurate for me to trust it to go off for a day, because those mistakes will compound on each other. But if actually the error rate was like 1 in a million times, then I can trust it to go off for a day. And I don't have to worry about those compounding errors in the same way. And the reason why, or part of the reason why inference is so expensive at the moment, part of the reason why tokens are so expensive at the moment is because inference providers, including OpenAI, Anthropic, all of these players, have built all of their systems to be real-time first, because their primary service is ChatGPT, and most of their clients are building like chatbots on top of their services. So they're built really for very, very low latency inference, which means you need to build in a bunch of redundancy. You're building at a much lower batch size. You're doing all of the optimizations that we would do if I'm trying to get low latency. And I'm just doing the opposite. I'm just doing all of the optimizations I can do to get low cost inference.
And you can do retries if it fails, because it's bad. You're offline. So if something does fail, you can rerun it, because you don't need, you're not real time.
Well, there's also an interesting thing about reliability in batch that we take very seriously.
Okay.
We have this. So if you ever use like batch providers like OpenAI or something, they fail pretty frequently. And if they don't meet their 24-hour SLA, then the whole job just kind of dies. And the reason why is like they just don't treat it like a first-class citizen. And they treat it in the, if your real-time API fails, it's kind of fine because it's such a short period of time, you just run it again. But they treat batched kind of in this way where it very frequently fails. We take the view that the longer we hold on to your request, the more responsibility that we have to get it back to you properly. Like if we have your request for 24 hours, it cannot fail. And if it goes above the 24-hour SLA, we really, really fucked up.
Because they've trusted you to make sure it works.
And they've wasted a whole day of their lives otherwise, right? And so we think, in line with we should be offering cheaper prices, we should also be offering a much, much more reliable service because they're trusting us for that long period of time with their and so that's another thing that I don't quite think other inference providers take seriously when it comes to batched.
We have another question, so we're going to have to read it and come back. But thanks, Meryem. Great response. Just to summarize, 3 things that should help. 1, vision, mission, and long-term plans. So that's a question. Maybe we start with that, and then 2, number of customers giving the same feedback. Is it statistically significant? And 3, operational efficiency and feasibility. Maybe we start with what's the vision and mission and long-term plans for Doubleword, and then we can come back to there's 3 questions in one there. So vision and mission and long-term plans.
I think Mohammed has like perfectly summarized my early response about like when should you take customer feedback on board. So for us, the long-term plan is we want to be the inference provider for when people are producing a lot of tokens, and those tokens really, really matter. So the use cases that we're most excited by are things like offline agents. We think these are going to be really, really impactful. And this is actually why people are pouring money into the AI space. And we want to be the inference tech that supports and underpins that. And so I guess like the second thing is like number of customers giving the same feedback. So what we hear from our customers is that typically they have 3 normally style of use cases and like within one organization. They will have some use cases that are super, super real time. So like a chatbot or a RAG app or something like that. That's like a proper real-time application. On the other end, they'll have a bunch of use cases that are properly batched, that they probably use the OpenAI batched inference endpoint for. So maybe things like data processing or synthetic data generation or evals. They're like batched workloads. And then they'll have something in the middle, which is kind of like it's async, but not batched. So maybe I have like a data processing pipeline that has like 10 different steps, and I can't have each step taking 24 hours, but this whole thing can take 3 hours, and that's fine. And so we are working with clients on those second kind of 2 use cases. For their properly batched workloads, what we offer them is just like cheaper prices than the OpenAI batched and more reliable service. And then for their kind of async workloads, what we're offering them is allowing to move to batched prices by having like a 1-hour SLA. And so we're working with clients on those kinds of use cases. And there's the pattern we see with our clients is they typically have 3 style of inference use cases, and we work with them on those either async or batched use cases.
And then how you then apply that is operationally efficient and feasible. So you have then the features that you are building that actually make sense for them.
Yeah, exactly. And so this, I guess, speaks back to the reason we're the right people to build this is because we're inference people. We've been inference people for a very long time. And so having a deep understanding of inference systems is helpful.
So as we are coming into sort of the last few minutes of this live stream, I wanted to come into the end with asking you for the advice that you, Meryem, have for builders, for people who are building AI-powered solutions. I know that we have had so much different advice sort of injected throughout the entire conversation. But if you wanted to leave people with a couple of pieces of advice that you have for them going into, as we are wrapping up 2025, if you were looking into 2026, what would be advice that you would give people as they plan for 2026? I'm sure there are loads of people planning their 2026 right now and what they are building in their companies. Like, what would you advise them as they are planning their AI, plans in, like, they're probably building AI features, because I'm sure there are loads of people being asked to plan for that. What advice would you give them as AI builders?
So this year, we really started to see use cases getting into production and getting to some kind of scale, and we should expect that to continue into 2026. All of the hard work you've been doing this year with building AI use cases, they're only going to ramp, they're only going to scale into 2026. You've probably been asked, or maybe have been asked, to support in figuring out inference budgets for next year, which is like actually kind of hard to do as your use cases scale. But as your use cases do scale, you do need to think about inference a bit more carefully than you probably did in your POC and experimentation phase. And the advice that I would have is, how I talked about the like trilemma that you have? You can have like
I love the word trilemma.
It's a good word, isn't it?
Love
You
it.
can have 2 of cost, latency, and quality. Pick which ones are right for your use case. What can you sacrifice? Is it a real-time async or batched workload? And then pick your inference stack to be focused around that. If you need super low latency inference, try out something like Grok or Cerebrus. Like that's like a super, super low inference route. If you just care about the, very, very low cost, like try out someone like us, or like try self-hosting or something like that. But as you get into scale and as you get into production, just understand what trade-offs you can make for your use case and then make the inference decision based on that. But understand the use case first and then inference provide a second.
That's an interesting one. Figure out the use case before you pick an inference provider.
We all have we're all good at different things. You shouldn't pick us if you're building a real-time coding assistant, but you shouldn't pick a nameless other provider if you're trying to do something at scale.
I think it's a really interesting perspective, and also like the self-hosting, going into self-hosting is also a big undertaking.
It's a huge undertaking, and so but it could be cheaper if you're doing it at a big enough scale. And so understanding your use case will help you inform what system you need for production.
And budgeting, by the way, I think budgeting is one of the hardest things. Like the amount of times in my career I've had to do my best at the, projecting how much money I want to spend on something the next year is so hard. And I think we always sit there the following year doing our best to try and figure out the budget, right? It's so hard. But I think then funnily now I feel if I was sitting there in 2026 at this, like, if I was fast forwarding, I was sitting in 2026 and I was like, oh, I have these use cases now. Maybe I have realized I have a bunch of non-real-time use cases and my inference cost is through the roof. I would probably call Meryem and be like, maybe I can rethink what I'm doing. And I think that would be a really good thing because I probably have a budget that I need to think about. Sorry, that's just like me connecting some dots here. I think it would be a good idea. By the way, for anyone wondering, I have nothing to do financially with Doubleword whatsoever. I've recently got to know Meryem, and I think this is a really fascinating space and really exciting. So I have, absolutely nothing more than that. Meryem is a wonderful person. I have nothing to do with Doubleword. So more than that, that she's here, but and she is not paying me to say any of these things.
Maybe I'll send you a t-shirt though.
Okay, maybe I'll get a t-shirt, but I do not have a t-shirt right now, so I might get one. But don't have one. So, but I do want to share some links as well. Any other advice or thoughts about the future, Meryem, while I share some of the links here for connecting with you?
I think so. Inference costs have gone down pretty much every year that we've been in the space, or every single year that we've been in the space, and cost per intelligence has also gone down by a lot as well. Like it's a super deflationary space, and so I think when you're building applications, don't be disheartened by what you project the inference cost to be, because the inference cost will probably be 10 times lower within a year for the same level of intelligence. And so that's like a really, really exciting kind of mindset to put yourself in, is don't actually, if you say find a great use case and it seems like it's going to be financially unfeasible, the chances are in a year it won't be. And that hopefully will allow you to work on like more ambitious and interesting things as well. So try and build without limits, try and build without thinking about cost constraints in your head, because they're probably going to go away in a year or so.
Awesome. I also wanted to share some other things as we wrap up. As I said, first of all, thank you so much, Meryem, for being here today. I really enjoyed the conversation, and thank you so much for engaging with the audience live and answering all of their questions. And thank you everyone who tuned in live and asked questions. It's really fun to have you here live. This is what I love doing, a live stream with people joining live and asking questions. That's the most fun thing about being live. I did show some QR codes there to Doubleword, the website. We've got Meryem's LinkedIn there on the QR code. But here you also get my LinkedIn on the QR code there up now. And if you want to try out some not batched currently inference, you can sign up to the Tetrate Agent Router service. That is all real time, but also some MCP routing. You can sign up to the Tetrate Agent Router service. But maybe we should get some batched routing. That would be pretty cool on that one. But you can sign up there for some free credits and try that out. And thank you everyone for joining live. It's been amazing. And on Thursday, we have Gleb from Electric Twin here.
So fun. You're going to have such a fun time.
And that's going to be awesome. So please join us on Thursday. Thank you, everyone.